Welcome to week 11 workshop CIV3SD1. Last topic for our subjects, and we are finishing our subjects by taking two examples for stiffness methods. One of the most advanced methods that we come across so far in the subjects. We have studied moment distribution methods, slope deflection methods. They are part of displacement methods, and this is also part of displacement methods. Those methods was developed about 100 years ago. Up to 1980s, engineers are using those methods. But this one, the space gauge software that you have, the stiffness methods is used in the space gauge software. So very advanced methods that we have taken the lectures yesterday. Some of the details that I think we already studied in the lectures. So I will not go over those details again, because otherwise it will take a lot of time to go on those basics. So I will start not providing those theories behind the stiffness methods that we covered last yesterday in the lectures. But let's solve these truss problems using the space gauge software. We have a guest lecture today. There is no any assessment for guest lectures or anything. It's just for you to have it extra knowledge and how the structure analysis or how the engineers works in the industry. You have an opportunity to ask. So I think 3 o'clock I will join the Zoom meeting from this monitor, the big screen, sorry. And students, if you wish, you can stay with here in this room, and just we will run it from this room for 1 hour and ask the questions. All right, in your assignments, you have a last examples in your assignment that is based on the stiffness methods. Probably next week we have a assignment due, so please complete your assignment questions. Next week we're going to just talk about the final exams. Everything is about final exams next week, that we're going to mention what allowable materials and so on. So next week's 4 hours we will talk about final exam. So let's start on these examples. What is these examples here? It says that let me check if I have a view of 100. That's all good. Yep. A 3 member truss. So you can see member 1, that rectangle one is numbering the member 1. Yesterday we discussed all these numbering and all these arrows and degree of freedoms and so on. Its geometry, dimension, modeling is shown in the figure. Determining the stiffness method of the truss K. Displacement at node 3. Need to find displacement D1 and D2. Young modulus is given, area is given, and the supports are pinned. So if I simplify this one, so you have this truss, and you have a pin here, you have a pin here, and you have a pin here. Right, so that's the truss problem that I just drew it again. Now, how many degree of freedoms here? Total degree of freedoms 8. 1, 2, 3, 4, 8. Yes, so each node has a 2 degree of freedom, so we have total 8 degree of freedoms. Out of 8 degree of freedoms, we have total 8 degree of freedoms. Out of 8, how many fixed degree of freedom and how many free degree of freedoms? Free degree of freedoms and the fixed degree of freedoms. So we have total 8 degree of freedoms. Each node has a 2 degree of freedoms. Total 4 nodes are there. Node 1, node 2, node 3, and so on. So therefore we have 8 degree of freedoms. Out of 8 degree of freedom, how many free degree of freedoms? 2 free degree of freedoms, that is correct, and remaining are 6 degree of freedoms, because at the 3 support point you have a fixed degree of freedom, which are zeros, and 2 are free degree of freedom, and free degree of freedoms are unknown displacements, which is D1 and D2 that we have it. All right, we are in this week's, the beauty of this week, we have only 2 equations. One that I'm going to show you, and another one also we're going to take it later. So 2 equations. Again, you don't need to remember those equations. It will be with you in your lecture notes, in your assignments, and in your final exams. It will be in the formula sheets. All right. So what is that equations? That equation is sitting here. That equation is called global stiffness matrix for member. If you have a members, any member that you take it, and you can find the global stiffness matrix. Now let's take the member number 1 here. So let's draw that member number 1. And by the way, they have reference, they have given you the global, no, if they don't give you the global axis, I can assume the global axis is here. That is the origin of the axis, because we need to define the coordinate 0, 0, starting point of your whole truss systems. We need to define. Why I define left and bottom? Because then I have whole systems which is in a positive coordinate. Why I define here? Because then I will have this positive, 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 and it's very easy for me to work with all positive coordinates. Rather than if I take it here, somewhere here, then this will be negative coordinate, negative, and minus, plus, and it's requires some attention. Why would I make my life hard by choosing something that I not friendly? So if in the generally it will be given. If it is not given, just take your truss, go far left, far bottom, and pick the point. Okay, so that is your starting point. So if I have a starting point, this is 0, 0, then I can write the coordinate which is x is 1.2, y is 0.9. Do you agree with me to write that coordinate? X is 1.2 plus 1.8, 3, 0.9. And the coordinate here would be 0, 1.8. Let me know if you don't understand this coordinate that I have written for the each node, which is the referencing 0, 0. I pose it here and tell me how I get any number that is puzzling to you. With reference to 0, 0 here, that is 0, 0. We going x 1.2, x 1.2, y 0.9, y 0.9, x and y. This one we just go across by 1.8, so 1.2 plus 1.83. We are not changing anything y, so 0.9. Same. This point we are not changing any x, 0x and 1.8. You notice, right? These coordinates have you used somewhere? So.
Is there any particular reason?
Yes.
336 is circled, or is it just so it's obvious inside the?
Which one? Sorry.
In the actual original diagram.
Yes.
Number 6 is circled, which is usually a node indicator.
Yeah, I think they just I think there is some type. There is some. We don't need to circle that one.
Just to demonstrate this.
Yeah, it's in the examples. Yeah. Yeah, so it's just 1 is correct. The 6, 2 is correct. Yeah, 6. I think it's just 6. So these books, they are not done by engineers like they know. They just did the hand drawing and the publisher just they make it fancy. These are not by engineers. They are someone who knows some kind of software to manage, and they just copy paste maybe. All right. So if everyone agree with that one, and member number 1 is this one with the circles, let's get the member number 1. So here we have a, let's say, member number 1, and we're going to find the stiffness matrix for member number 1. So let's draw the member number 1. Look, in the exam or everywhere, you don't need to draw all this stuff. Okay, you just keep in mind and you just use the original figure for that one. So you have 0, 0 and 1.2, 0.9. Now, if I want to calculate the length of this one, then length would be square root 1.2 square plus 0.9 square. Square root 1.2 square plus 0.9 square is 1.5. So length is 1.5 meter. Then these location vectors will give me, this is the near node, this is far node, this is number 1. What else we needed? This degree of freedom 5, 6 and 1, 2. So we have a 1, 2, 5, 6. Right? Anything else? I think that's it, right? So I redraw this element number 1 from the figure. I put the original coordinate 0, 0, 1.2. Length we calculate by using Pythagoras theorem, 1.5 meter. We have the 1, 2 degree of freedom, 5 and 6. Near node, this location vectors, tail is near node, head is far node, and so on, right? Raise your hand if you puzzling something.
Do we need to worry about the force at that point at F or the far end? We need to worry about this.
Not at this stage. Later. I will show you the Excel as well at the very once we finish that one, that how we can use Excel.
Seems like something Excel would do very. Especially by hand.
Yeah, look, Excel will do, but we need your this math skills and all your brain processing skills. When you go on the workplace after 1.5 years, we don't want to just. Any technician can do it. If I train year 12 students, open the Excels and plug those numbers and change those numbers, anyone can do it. You know what I mean? The beauty that we want to have, the Excels and all that is just for you. I don't want you to just blindly follow and then you end up with some answer and student send me the email. Can you check? And then I said, okay, you check it. Here is the Excel.
Yeah.
See, so that's save my time. I need to just give you extra tool that will help you to understand. When I see that when students use Excel, it will just help them to connect the maths and the software side. MATLAB also we can use, but I don't want to go on that part right now. That will overcomplicate the stuff. All right, so now we have to calculate this lambda x and lambda y in that equations. You know that one, lambda x. Then you have this one is near node x, near node y, far node x, far node y. So far node y, sorry, how do we do it here? I think so. Far node x minus near node x over length, which is 1.2, take away 0, 1.5, which is 1.2 over 1.5, which is 0.8. Lambda y, fy times ny over L, which is 1.9, take away 0 over 1.5, 1.9 over 1.5, 1.27. Oh, sorry, that is 0.9, not 1.9. So 0.9 over 1.5, 0.6. Right, so lambda x, lambda y done. Once you done this one, you can have these equations that we want to get it from our lecture notes. Where is it? This one. So we can take these equations here. All right. These equations in front of us. Capital K1 equal to AE, length is 1.5 meters. I'm not writing the unit. Lambda x square, which is 0.8 square, which is 0.64. 0.8 times 0.6, which is 0.48. I'm just plugging the value, by the way. Minus 0.64 minus 0.48. And you know the story from yesterday, you know this one, right? Make sure you don't do it if you're not confident to these rows and columns. And these numbers here. Let's check. I think you know the symmetry, right? These numbers in the row should be same as this number. These numbers here should be same as this one, and so on, right? So all the rows and columns are exactly the same. It's a symmetric matrix, so you never get wrong, right? And the numbering that we're going to use is 5 6 1 2 5 6 1 2. Right? So near node X, near node Y, far node X, far node Y, and similarly this one. Any questions? And we just going to get this one in 0.64 divided by 1.5. 0.64 divided by 1.5 is 0.43, and 48 divided by 1.5 give you 0.32 minus 0.42 43 0.32 0.36 over 1.5 0.24 minus 0.32 minus 0.24 minus 0.32 minus 0.24 0.43 32 32 5612 5612. I just divide the whole things by 1.5 and make sure that these rows are same of this one. This row same this one. This chunk number here is same as this one. These numbers here are same as this one. This is symmetric matrix. Yes, please.
Since we've been given the area and the Young's modulus, wouldn't it be better?
Not right now, and it may cancel. When you have a displacement, when you inverse the matrix, they will cancel each other. If I plug it right now, it will be just extra work for me. No problems if you like to do it. There is no any issue. But I know from the lectures that we done yesterday, we done 1 over AE when we do the inverse matrix, and we have AE here. They will be cancel each other when we do the displacements. We will see. If it is required, then we will plug it later. But I don't want to, there will be huge numbers if I put those AE here, and I can't write in a matrix if I know those big numbers. Right. So K1 done, K2. Member 2. Let me draw the member number 2. Here, member 2 is horizontal one. If I have horizontal one, that would be much better, because then your one of the lambda x and lambda y would be 0. So 1 2 3 4. So that would be 1 2 3 4. This is near node, this is far node, and then what else? 1.8 meter length 1.8 meters. The coordinates is 1.2 0.9. Coordinates 1.2 0.9 3 0.9. Right. So I just rewrote this member 2. Coordinates near node, far node, number 2, 1, 2, 3, 4. You don't need to draw it every time. So you can just use your original figures to just calculate those things. And then lambda x equal to 3 take away 1.2 over length 1.8. It gives me 1. Lambda y 0.9 take away 0.9 equal over 1.8 equal to 0. And now let me copy this and we're going to paste it here. And if I have horizontal member, vertical member, that is better because one of the things would get 0. So K2 equal to AE over 1.8 lambda x 1 0 minus 1 0 0 0 0 0 and minus 1 0 and 0 1 0. Make sure that this row, let me grab a little bit up. Make sure this row 1 0 minus 1 0 same here 0 0 0, this one same. Not by copying, but when you do the calculation, do the rechecking, okay? That these rows and column, because it's a symmetric matrix. Again, these 4 on here, they should be same here. These 4 here, they should be same here. So you never get wrong. You have a double, triple checkup, okay? And then you just give this one in 1.8. So 1 divided by 1.8, you get 0.56. 0.56, 0 minus 0.56, 0, 0, 0, 0, minus 0.56, 0, 0.56, 0, 0, 0, 0. And the coordinate that we're going to write 1, 2, 3, 4. Easy. 1, 2, 3, 4. 1, 2, 3, 4. That is K2. Raise your hand or questions, anything that can help you to understand. This is how the space gets doing your calculations. After studying these methods, even you can build your own program like a space guess. What you need, you just need the coordinates that you draw. Remember that? It asks you to draw. Yes, please.
Could you just quickly scroll up for us?
Yes, please.
Bit more. On to the previous matrix.
Previous matrix, yes.
Does that matter which order you put like the 5, 6, 1 to it?
It is matter.
It does matter.
It matters. You need to have it near node X, near node Y, far node X, far node Y.
The node X, node Y.
Everything is matter. Otherwise, you will see when we assemble the matrix, it will be a huge job. If you miss one number here and there, but I will give you the stop sign where you can stop and make a check. So because it's a long process. If you make a mistakes at the start, it will be your mistakes will be amplified. The mistakes will carry over all the way to the end. Right. So K2 done. I think the process is repeating. There is nothing we can do now. K3. Let's draw the third members. Member 3. That is 1, 2, and then 7, 8. 1, 2, 7, 8. And going down, number 3. So this is near node, this is far node. The coordinate that we wanted is 1.2, 0.9. 1.2, 0.9, 0, 1.8. Lambda x is equal to 1.2, take away 0. And by the way, the length calculations is 1.5, because I think this is horizontal 1.2 square plus 0.9 square. So that would be 1.5 meters. 1.5, 0.8. Lambda y equal to 0.9, take away 1.8 over 1.5, you get minus 0.6. Right? Students who did not attend the lectures, I think it's a little bit boring or a little bit distracted, because I think we can't cover a lot of theories that we covered yesterday. So if you want to watch that, it's not waste of time. You will feel more confidence using the stiffness methods, because you will have a background story what's going on. So there was a recording. If you missed and if you're interested, you can just go and watch it. So it will give you more insight. Otherwise, it will be boring for you to just blindly follow those equations and plug the value. We have covered those theories in very great detail. So, okay, so now we have lambda x and lambda y, and then we can just put that. Now this minus sign will give you a lot of this minus sign will helpful. Okay, helpful meaning that it will clear one concept that is very important. And I will show you what is that concept that minus signs will bring for us. Now, K3, capital K3, KE over 1.5 length. Look at this minus sign that you have it here, okay? Now, these minus signs here, that is this minus sign that is outside of lambda x. So if you have a lambda x minus, do we have lambda y minus? Yeah, you don't have this one here. So I will show you that you have this 0.6. If 0.6 does not mean that you need to make it plus, right? It's 0.6 square. So this minus is not square. It's not plus. You understand what I'm trying to say? This minus sign is just outside of lambda y square. So if you have a negative, then you need to take this negative 0.6 square, which is positive, but still it is negative. I will show you that one. But that negative signs that will be kind of 0.8 square, which is 0.64. 0.8 times 0.6 minus 0.48. So this is minus sign, and 0.8 square is 0.64. And this one minus sign, and I will write it this one for you, 0.8 times minus 0.48. So that become sorry, minus 0.6. So that become positive 0.48. So I hope it is makes sense. And then you just copy this line. Don't copy it if you're not confident. Just do the plug and chug values and then compare it. Then 0.36, 0.48 minus 0.36, positive 0.48 minus 0.36, 0.64 minus 0.48 minus 0.48 and 0.36. And we will write the coordinates later. And then AE 0.64 over 1.5, which is 0.43. 0.48 over 1.5, which is 0.32 minus 0.43 minus a positive 0.32 minus 0.32 minus 0.43, 0.32 over 1.5, 0.24, 48, 0.32, 36 minus 24, 0.32 minus 24, 0.64, 0.43 minus 0.32 minus 0.32, 0.24, and we have near node first 7812. Right. I will give you one trick that you don't need to write all of them. Right? You don't need to write all of them, meaning that it will be matrix 8 by 8. So it are a lot of numbers, but I will give you a trick that you don't need to use when you do the calculation for displacement and when you do the calculation for reaction forces, or there are three calculations: reaction force, internal forces, and displacement. I will tell you in the assembly of matrix, you don't need to write all of them. And the next question students will ask me, do I need to write it in the assignments? You don't need to write in the assignments. Do I lose the marks if I don't write the? You're not going to lose the marks. Therefore, I want to see your understanding that why you don't write those numbers, right? Because if you not attend a lecture or workshop, you will follow the workshop examples and all. They will write. And for us, as a part of the theory, we need to write. But if there is no meaning, engineers, we just don't want to blindly put all these 8 by 8 matrix. Okay. So for that, I like to give you some idea here. That at the start, do you remember that we done this? 2 free degree of freedom. That is 2 unknowns. So when we partition the matrix, we will do this. Just stay with me, okay? Q is equal to KD. What is Q? Force is equal to stiffness times displacement. And that is the relationship that we use it, right? Stiffness is equal to load over displacement, right? So in this one, we will have this big force matrix, which is 1, 2, 3, 4, 5, 6, 7, and 8. You with me? Because we have 8. And then you have K matrix, which is also big one, which is 1, 2, 3, 4, 5, 6, 7, and 8. You with me? And 1, 2, 3, 4, 4, 5, 6, 7, and 8. And that is a D matrix. Again, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so this is Q, K, and D. Right. So now that is the things that I want to show you. That will helpful. Okay, so you draw the line from the two. You understand this? How I draw the line? Because we have 2 free degree of freedoms. Everyone understand how I draw the line? If I have 3 degree of freedoms, I draw the line from 3. If I have 4 free degree of freedom, I draw the line from 4. Everyone understand clear? Okay, this is not part of that workshop, or yesterday we did not capture in the lectures, because I don't want to give you this concept at the start. Once you done the long way, then you will respect the knowledge. So when you draw the 2, you draw the line from 2 here as well. Do you understand that? 2 horizontal, how you draw it? Because you have 2 free degree of freedom. How you draw it here? That you just draw the vertical, and if I have 3, you draw the line from 3. If I have 4 here, draw line from 4. Everyone understand? Okay, now in the K, what we needed? We need just this. Sorry, we don't need We don't need this. We don't need this. We don't need this. We don't need this. We don't need these numbers. 3, 4, 5, 6, 7, and 8. We don't need this green one. We're not going to use them. Why? Because look at this one here. I will tell you why. Because 3, 4, 5, 6, this is 0. These displacements, because it's a fixed degree of freedom, these displacements are 0. So anything multiplied by 3, 4, 5, 6, 8 would be 0. Because this line, this horizontal will multiply by this vertical. Right? So you don't just going to use this one that will multiply by this one. You're going to use this one that will multiply by this one. This green one, if you write it, they become 0. So for you, in the assignments, in the final exams, whatever you're going to do it, you can. I need to go there. Okay. You need to. You can just put the line here, dash line or something, and I will understand why you put the dash line. Okay. So that's the understanding that I want you to. So you can save the time. Because students will understand that, okay, that will multiply by 0. Why do you write it, right? Now, how are you going to get these numbers here and here? Just give me a minute. I will just turn off this computer on the next door. Otherwise, it keep beeping. All right, so now we just need those columns and rows 1 and 2, and that's it. That's simplified a lot of works. Okay, so over here, Q1, Q2, that is your. You can look at the figure here. Look at 1. 1 is 0. There is no, but Q2 is minus 20. Look at the figures. Okay, so Q1, which is Q1, and this is Q2. This is Q3, Q4. So Q1 is 0. There is no any external force going in the 1, but there is a in the 2. There is a force going in the 2 degree of freedom. So that would be minus 20 because it's going down. So I can write 0 here minus 20. Q3 reaction force we need to find, Q4 we need to find, Q5 we need to find, Q6 we need to find, Q7 we need to find, Q8 we need to find. There are reaction forces. Right? And then here 1 and 2. So 1, row 1, column 1. Stay with me here if you did not attend the lectures yesterday. So you have row 1, column 1. So that is the element here. So we need to go on K1 first and row 1 and column 1. So K1, row 1, column 1 is 0.43. Take this 0.43, row 1 and column 1. So let's say 0.43 plus K2, row 1, column 1, 0.56 plus K3, row 1, column 1, 0.43. 0.43. So you got 0.43 plus 0.56 plus 0.43. You got 1.42. Raise your hand if you don't understand this. Row 1, column 1, and 1, 1, you get 3 out of 3. Now second one, column 2, row 1. Let's get it. Now here one trick I like to give you. Can I borrow your? I will use the play. So if you in the exams, if you are using the sheets, you want to structure your K1, K2, K3 in a way that you can. You're not going to do this. You might end up by taking more time, taking the mistakes. So plan your K1, K2, K3 in a way that it will be visible for you all the time. Okay? You understand what I'm saying?
Yeah.
So otherwise you will do this up and down for 50 times, and in 15 you might put up one number taking in the front, and you end up with the wrong answer. All right. So keep your work visible. That's K1, K2, K3. I'm not sure how. When you practice your assignment questions and all, you do that practice. Then it's not rules. You can do this other page. It's up to you. But you don't want to play smart against those maths ones. So that's the. So you have a column 2, row 1. So let's go K1. Column 2, row 1, 0.32. So we have a 0.32 and row column 2, row 1 is 0. So don't worry about it. And column 2, row 1 minus 0.32. So minus 0.30. So that is 0. All right. Students, can you please do this? Can you please fill this one for me? This would be 0 by the way, because these numbers comes here, but check it. And can you fill these numbers? And we will cross check with each other if it is working. You know what is your task now? Fill this number, fill this number, fill this number, fill this number, and tell me one students, and then we will cross check. Possible? Raise your hand. I will come to you if you don't understand. Solution don't have answers, so you need to do it by yourself. Because these solutions has a .64. Maybe I did something. So column 2, 1.32 positive. column 2, row 1, 0, so don't count. Column 2, row 1, 0.32, right? Minus 0.32, positive 0, but they are not matching. You see? So one of them need to be checked. So how do we going to check? Is negative? Is your right? We can check on the solutions. Q3. Oh, minus 48 minus. So both are minus. Yeah. Right. So yeah, dimensions. You can do the cross check by yourself by looking at row and column.
Be identical, but still check.
Now it's better. Is 0?
Yeah.
Okay, very good. Once you finish, raise your hand and we will just the one students. Just tell me the answers and we cross check with other students. Yes. No, not this number. This number should come here. This number should come here. This number should come here. These numbers should match not with this one, but this number should match with how 1, 2. Yeah, it should.
I get what you
Somewhere match.
So it should be like the same thing, row, and then.
That's it. Yeah, that's it. Yes. Think of if you want to do all of them, that will take 1 hour, and you make a mistake in between. That's different. Let's check if others. Let's give them some time. So. Do you want to say it? The numbers that you got? And then other students will cross check, and if it's not matching, and then we will check. Yep. So 1.42 here. 0 maybe. Here 0 as well. 0.48. Okay. Here. Negative 0.56. 0. 0. 0. Negative 0.43. Negative here as well. 43. How much? Oh, thank you. Thank you. That is here. So 0, 0. Oh, 32. And then 32. 24. 43. 52. 32. Oh, yep. Minus 0.32 and that's it.
Negatives. I got 5.
I got a 3.
Which one?
Yeah.
There's 0.52.
This one?
Yeah.
What is that?
I got 0.32.
0.32. 32. 32.
Yeah. Right. My bad handwriting.
Yep, that's good. 32. Okay, so we change it to 32?
Yeah.
That's fine. Right? Anyone did get a different answer, just brave enough to just say it. And we will cross check. We can cross check your solution as well, and we learn from that what mistake it comes, where this comes from, and we make sure that will be avoided in the future. Everyone understand so far? Can we move on, or anyone falling behind? We are happy to stop here, and in case anyone's still working. All good. All right, then let's go. So here, D1 and D2, that's we need to find, and these are supports. You know, pin supports there, right? They are 0. That displacements at 3 pin supports are 0. If you look at that D3, D4, they are 0. There are fixed degree of freedom. Fixed meaning 0 degree of freedom. Right? So therefore, we have this green one, guys, that 3 will multiply by 3, 4 will multiply here, 5 will multiply here, 6 will multiply here, this will multiply here, this multiply again with this one, then it will get 0. So there is no point to writing it. Right? So we reduce the large amount of work here, plus we reduce the errors. Otherwise, you will end up with lots of errors. And my suggestion is, in the exam, and if you have time, don't just sit down at the end. At the end, if you have 5 minutes, come back and cross check all the numbers that you have. Okay. All right. I know it is boring, but this is how it is. Yes, please.
Would you do the whole thing in the assignment?
No.
Or just the three?
I don't want to create any inconvenience for the students. I'm here to teach you, and if there is no point, you don't need to understand why you're not writing it. Right? And the students, so I will pick it up that, oh, these students comes in my workshop because they just think. Okay, so we can separate those two groups, right? But there is no harm. I can't force anyone to come in the workshop or lectures. But if you attend the workshop or lectures, you will have some freedom to save your time. All right. Anyway, so there is so in here, what we're going to do it? We just take these first two guys. I think this big part is done now. And then, oh, by the way, there is AE here. Don't forget to write AE. That is very easy to forget. And you write AE here. And 1.42, 0, 0, 0.48, and D1, D2. Do you agree for me to write this one? This part here, 1, 2, AE, this here, D2. Right, and we have this matrix, we can use D1 and D2. Yes.
So it's not negative 20 anymore?
Oh, yeah, sorry, I just minus 20. All right. Now, if you don't know the matrix, I can still revise you. Let's say this is A equal to BX. Then if I want to do this B inverse A equal to B inverse BX, B inverse B equal to 1, so X, so B inverse A. You know the story, right? If you don't know, that's fine. That is new for you. You multiply by B inverse both sides. You have matrix A, you have matrix B, and you have matrix X. Then you multiply B inverse here, multiply by B inverse here, and then B inverse A. This will become B inverse means 1 over B. So that is cancel each other and X, right? So we need to get the B inverse and times by A to get the D1 and D2. So X is D1, D2 is equal to B inverse. This let's keep this one as a separate right now. B inverse is a dat 1.42 times 0.48 minus 0 times 0, and we swap this diagonal and we put the minus sign in front of 0, but that does not matter. And then you multiply by 0 minus 20. If you don't know the B inverse, please give me 1 minute here and I will explain you this one. All right, look at here. X is D1, D2, that. Oh, sorry, I need to get that matrix here. So determinant. You cross this 1.42 times 0.48, take away this cross multiply. That's how you find determinant. Then in here, you swap those numbers and you put the minus in front of it. I just put the dummy minus to complete the procedure, but you don't need to write it. But you swap these numbers. You don't swap this number, but you put the minus in front of that minus, and 0 and minus 20 is coming here. AE will come. So they will do 1 over A. They will. I will show you. It's just A is there, but I don't want to get too much AE and all. All right. So now, if I have this one, then 1.42 times 0.48, you get 0.68. 0.48, 0, 0, 1.42, 0 minus 20. So here you have to divide by 0.48, divide by 0.68, you get 0.71, 0, 0, 1.42 divided by 0.68, you get 2.01, 0 comma minus 20. So D1, D2, 0.71 times 0 plus 0 times minus 20, 0 times 0 plus 2.01 times minus 20. So you get D1, D2, 1 over AE, 0. Over AE. What? Because
Then you just subject to the D.
yeah. And then we're going to plug this AE. For your questions, if I done the AE at the very start, I would have very huge numbers. I just keep it AE as a constant. If you have a different A value for each members, you need to consider those one in the K1 and K2. But if A is same for each trust member, then you can do this procedure. But if someone give you that A is different from member 1, A is different from member 2, and member 3, then you have hard time. Hard time meaning you need to do K1, K2, K3 considering A. And then you have those huge numbers that you need to sum them up to get in the K, and that's possible. But if it is A constant, you can keep it ideal until its end. All right, so we're going to plug the values AE, and the AE is given in the form of E equal to 200 gigapascals. So what we are working length in the meter and load in the kilonewtons. Do you understand that, right? We so far in the matrix, we are taking length in the meter and the load in the kilonewtons. So we need this one into kilonewtons and meters. Do you agree with me? So gigapascals, we can say that 200 times 200 times 10 to the power 9 pascals, which is 200 times 10 to the power 9 Newton per meter square. Convert into kilonewtons, 10 to the power 6 kilonewton per meter square. Do you agree with me? So E is good now, is in kilonewton and meter. Area is given to us in the millimeter. Area is equal to 300 millimeter square. So 300 divided by 1000, again 1000 to get in the meter square. So far so good. This block here, AE, 1000 millimeter equal to 1 meter. You have 2 millimeters, so you divide by thousands, two times. 4, sorry, please, 3 times 10 to the power minus 4. All right, so now we're going to plug the value. 200 times 10 raised to 6 times 3 times 10 raised to minus 4, 0, So that would be multiply by 1000 to get it in millimeters. And this minus sign indicates it is going down. If you do this examples via what methods that we can use, I think we have a force method that we can use, or any method. This is indeterminate, highly indeterminate. You can see there are 6 reaction forces that we need to find. And I will show you how to get these the reaction forces as well. It's not part of this one, but I can show you once you finish this one. I can show you how to find the reaction forces and internal forces as well. Okay. It's not part of this example, but I just want to show you for the completeness of the methods. So far, so good. Now we go back to this matrix again. And we take these guys, Q3, Q4, and Q8, and we take these guys here, and we take it with the D1 and D2. So let's rewrite that. Q3, Q4, Q5, Q6, Q7, Q8. AE 1.42, 0. Can just someone 1.42, 0, 0, 0.48. Can someone just tell me these columns here, please? Can you just, what is it? 5, 6, yep. 0, 0.
So 0, negative
0, negative 0.43. 32.
negative 0.4.
43.
Yeah, 0.32.
I guess we have to start from rate.
Yeah.
Sorry, what happened?
Did you start?
Oh, yes, sorry. We need to start with this 0.5600. Okay, sorry. So you have 0.56000. Now can you say a column first? Yep.
Negative 0.32.
Yep.
Negative 0.4.
Yep.
0.32.
Next one.
Negative 0.32. 0.2. 0.2. Negative 0.2.
Okay. And then you have a D1 and D2. You can check it. Right? And then we just substitute this D1 and D2, which is 1 over AE 0, comma minus 40.2. So we can cancel these AE and AE, and for Q3 equal to minus 0.56 times 0 plus 0 times minus 40.2, which is 0. Q4, which is 0. Q5 minus 0.43 times 0 plus minus 0.32 times minus 0.42. So 32 12.9 kilonewton. Q6, this is 0 plus 24 9.65. Q7, first one is 0, 0.32 times 40.2 minus 12.9 kilonewtons. Q8, 0 minus 0.24 minus 40.2, 9.65 kilonewtons. Raise your hand if you have questions for reaction forces. Yes.
So why doesn't it equal 20?
Is it not going 20 in total?
1.65 plus 1.7.
Yeah, that's kind of rounding error if you consider that way. Because you see, we have many numbers in the stiffness that we rounding off from the start to end. That's just 2 decimal places, 1 decimal places. Yes, please.
Saying, if we look on the picture, is that saying that zero is actually
Q3 and Q4 is 0.
zero?
Yes, that's right.
5.
Q5 reaction force, horizontal reaction force 12.9. Yep. I think you asked a good question. So let me clarify that one here. So if you don't ask questions, yes, please. Yes. So. Yep.
Going up.
Yeah. Good.
Yeah.
Okay. Yes, you asked a good question. So if you don't ask questions, I can't explore more. So I think you raised a very good one. So let's share with others as well. So where is it? Where is my? Okay. So here. Let me get this one. Copy. Sorry. Control V. So what's this one indicate? At Q3, the reaction force here is 0. Reaction force here 0. Q5 12.9. So you have a reaction force here which is 12.9 kilonewton. Q6 reaction force 9.65 kilonewtons going up. Q7 which is going opposite, which is by the way this way, which is 12.9 kilonewtons, and this one going up 9.65 kilonewtons. So that's how it's putting into the diagrams Q all the reaction forces. Right, and that's 9.65, 9. Sum them up, you will get a straight line. And this 12.9 going this way, 12.9 going this way. So you can cross check at the very end that your answer is right or wrong by doing this equilibrium. So you never ever get the wrong answer. There are steps that you can cross check.
Wrong answer.
Yeah, you can get the wrong answer, but not as a disaster level.
Yep.
It's not like you blow everything up.
Yep.
You get the wrong answer. I can't deny on that one, but you can't just say completely upside down. All right. Now Excel. Can please open the Excel? And by the way, I need to show you that I need to show you that internal forces as well. Let's do the Excel first then, because we already said. All right. Let's say what input do we need? Let's put input here.
Nothing on the screen.
Thing on the screen. Okay. But it's not connecting it. It could not connect. Cancel. Oh, yep. There's something doing now. All right. Yep. Okay, so open Excels, input, and then we can just first get this matrix K1. So let's say if you want to K1, what input do we need? We just need what we did. Let's say near node X, near node Y, and we need far node and far node Y. You know how to get this one, right? So this one 0, this one 0. Far node X is 1.2 and far node Y is 0.9. You know how to get this, right? From your member, you can put near node Y, far node, oh sorry, far node Y. Sorry, this one far node Y. are all your inputs that, by the way, the Excel will require for you. And then we will have length of the members. Length of the member is 1.5. Right? Okay, now everything. Oh, if you want to put A and E, of course you can put it. A is what A? 300 divided by 1000 times 1000. That is your area in meter square. You want to put area. I think we need to share the screen or.
Me.
Oh, you. Okay. Yeah, so it's running. No students, so that's fine.
On in the meeting.
Otherwise, I thought my one is.
It was me.
That's all right. Thank you. All right. Now, we will have a 200 times by 10 to the power 6. I believe. 10 to the power 6. Yeah. So all are in the same units, and everything is nice. So that is, by the way, the member one that we talk about. Raise your hand if you fall behind in the Excels, and if you're working with me and you have questions. Now, once you've done this one, we look at these figures here, and let's say I want to develop the K1. So the lambda. So let's calculate. Okay, now the calculations start here. Let's say this is our input, and calculations. Let's do the lambda x, which is 1.2. Take away fx minus nx divided by length. Right, so you equal to bracket this fx times nx is a lambda x. Enter. Lambda y, you get fy, take away ny divided by length. Enter. So far so good. And let's do the K1 here. K1 equal to lambda x square equal to lambda x times lambda y equal to minus lambda x square. And look, the trick is here. You just need to put the bracket. And that will match. Okay, because the Excel will think that you are putting the minus in front of that. So equal to minus lambda x times lambda y. And then lambda x times lambda y equal to lambda y square equal to minus bracket lambda y square. Right, equal to minus minus lambda x square. Minus 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 raise your hand if you have any issue in putting those numbers in the Excel. All right, everyone got it so far? Now we can just multiply by AE. So let's say K1 and let's say equal to 0.64. I think we need to multiply by AE and divide by L. So multiply by area, lock it up because we're not going to change that one. Constant times by E, lock it up. Divided by length. Again lock. Require packet. Where? Which one? This one? No. You year 9 bracket. There is a I don't know that short form that you have bracket first, multiplication after. Do you know that? You don't know. Huh?
I don't like bracket.
I know you like bracket, but you can put the brackets. Look, but it will give you the same answer. I can show you. So look, how I understand this. How the Excel gonna do the multiplications? It will look for this bracket or division first. It will look for multiplication first. So it will take this number, multiply by this number, multiply by this number, and then divide by this number. If you have a plus, then they do the multiplication first, and then they look for the plus. I think it's very complicated for you, but you can put brackets.
I remember block math, which is.
Yeah, that's the one. That's the one.
Division, then multiplication.
Yes, division and then multiplication and so on.
So wouldn't it divide first and then?
Yeah, so that's fine. You can divide this one by this number and then multiply. You get the same answer. Doesn't matter. Yeah. So year 9 that I used so far. But at that time you think, where I'm going to use this one. It's very, very helpful. Those fundamentals that we learn in the schools. We still, I used to teach, when before joining this one, I used to teach maths to those kids from year 1 to, I go to their home and I teach them. That's how my fundamentals get very strong. So it's very helpful. So I think that you say that this applied here. If I put the brackets, it will give you the same answer.
If you worry about it, just do A with the L set.
But if you wanted, you put the bracket as many as you wanted. There is no any issue. There is no hard and fast rule. So this is good. Let's do this one and make sure that they will give you the same thing. Yep, that's perfect. That's perfect. And select this 4 and drag it down. 1, 2, 3. Bang. This stiffness matters. See? Just hold it. And if I change those numbers only, they will change everything here. And now you have a 1, 2, 3, 4. I think you have 5, 6, 1, 2. So K1. Let me put in that format. 1, 2, 3, 4, 5, 6. Something wrong? Oops, sorry. Which one?
It should be negative.
It should not be negative.
Because it
No, that one there. Yep.
should
Thank
be
you.
negative.
Yeah, so we can fix that one. That one there, and that's fixed, and that's fixed. Everything else. So how many degree of freedom we got? 8, 1, 2, 3, 4, 5, 6, 7, and 8, right? And this one here, we got 5, 6, 1, 2. 5, 6, 1, 2. So eight. Any questions? I just take it 1, 1, 1, 1, 2. So I just copy this whole thing here. I copy this 1, 2, 5, 6, 1, 2, 5, 6 here, 5, 6, 5, 6, 5, 6, 5, 6, 5, 6, 1, 2, 5, 6, 1, 2. Even done. Now we're not going to do all this one by hand now. The magic will start now. That for this one, if I change the number here, which is K2 has a lambda x, nx is, what was that? This one 1.2 and 0.9. Look at the numbers are changing. And then your fx is 3 and 0.9. Is it correct? And the length is 1.8. Right? You got K1, and these numbers should be changed as well. This is red and in the middle, and this will change in the middle. So let's change those numbers. Now this one 1, 2, 3, 4. 1, 2, 3, 4. Now let's do the K2 here. Copy this. Copy this. Will be. Let's copy 1, 2, 3, 4. And then these are zeros. K2 done. K2 done within 30 seconds, I think. Not more than 30 seconds. K3. NX. Zero. NY 1.8. And 1.2. And 0.9. The length is 1.5, I believe. Yep, perfect. And now the A18 1 2 7 8 1 2, and let's do the K3. Let's copy all this one. Control C, Control V, K3. Let's remove all these numbers. And here you go. 1 2 1 2. So here you go, 1 2 1 2 blocks. Then you got 1 2 7 8. 1 2 7 8. Then 7 8 7 8. So 7 8 7 8. And last one 7 8 1 2. And all others are 0. Raise your hand. I can come and help you if you need help. You don't need to do this one for your assignment or for anything. It's just for fun activities. All right. Now K, capital K. Just need to sum them up, right? Capital K equal to this number plus this number plus this number, right? And then you just do this. Check it if it's going right. Yep. And then you just do this. Is it different? Oh, I did the K. Okay, let's start again. Focus. All right. You are watching? Equal sign. K1 plus K2 plus K3. You can see this 3 plus. Get it? Then use this plus sign. Bang. And then you just drag it whole down. Now if I change the number up, this number will change. Right? Even you can do more automated stuff as interactive as you want to make it.
Some sort of whole thing on
Yeah, the whole thing. That's how the space gas is working. Therefore, this computer likes this stiffness method because it's well structured. You don't put those numbers here, there. It is well defined. It's 1, 2, 3, 4, 5, 6, 7, 8. Okay, likes it. Okay, you have 8. Okay, that's fine. This. They know which numbers to plus, which numbers to minus, which numbers to do it. You are giving area, you are giving young modulus. Do you remember in the space gate? This is how they use it. And then once they do this all, and they will just grab the element and they will give you the displacement. Raise your hand if you stuck somewhere. And there was one more example, but I think it's just repetitions. But I will show you one how to calculate the internal axial force once this Excel exercise is complete. Even it's help you, this Excel help your brain to understand the whole process, how on the paper it's working. MATLAB is much easier than this one, but it will just give you extra things what is happening there. I don't want to add that one. Come in our master program, we will get one more step ahead. Abacus, MATLAB plus and calculation, 3 things together. Yes.
Trying to figure out how to get pieces table.
How do we want? What do you? Sorry, what is your question?
So
Yeah.
I would be saying, yeah.
You want to calculate the Excel to the Excel. You want to calculate displacement to Excel.
Yes, you'll see.
Yeah, I need to check whether we can just do the inverse matrix in the Excel. I think it's possible. Yes, two matrices inverse and more calculations. But I think I don't want to give one more step because after this same calculations is through. All right. But I think we stop here in the Excel. But if you want to take one step further, now is your call. How you? This is my. I give you the letters. You can climb as big as you want to climb. So 55, we're going to stop the workshop. And we're just going to switch back to the Zoom. You're more than welcome to stay if you have something else to do, because it's outside of our workshop. If you have something else to do it. If you want to stay 5 minutes, 10 minutes, if you get too bored. I'm not sure how good it is. The first times we are inviting that guest lectures. So I'm not sure, but it's just every week, every subjects that I teach, I generally have to have this industry exposure, at least for 1 hour or something, to just give a students opportunity, not sitting in a classroom, but just see how the outside world looks like from the classroom. Yes.
Question back in.
Yes.
Target, and now if it does come up with my new question.
Instability found for the rotation about y and no.
My question.
I got it. Yes, I got it. Sorry, I got it. Okay, so
The origin.
yes, yes. Yes. Says that
I put in the,
no, the value, these errors comes from here. The errors come. This is
same third one.
Instability found for rotation about x-axis.
So which one you pick, you can say. Bedroom. Bedroom. Under two.
No, I think just send me the question file, right? Let me do it myself and see.
I'm getting annoyed because I'm like, I can't get past it.
That's okay. No, don't worry. I will just send me the question. Just send me the email.
Yep.
That's why it will
Do you
stay.
want me
in
to
the-
send you my file?
Hmm?
Do you want me to send you my file?
No, I don't. I don't need your file. Just I will do it in my computer.
Thank you.
Yes, please.
I had a question.
Yes. Yeah.
Yeah. This assignment. From the opposite directions.
Yeah, but they put the negative. Can you put the value? $3.51. You got 4 point.
It's rounding errors. Not the-
What's the reaction force?
I did try to calculate it, not anything, but my reaction forces were the opposite direction. It was one of the questions where my I think this one's right. It's not a good question. Would have been a question.
You draw it, but you have solution.
It's in my space test.
You already have it? No, you don't have it yet. No.
Hold on, I'm confusing myself. It should be in the
You take your phone.
Yes,
You talked to me with this the other day, I put not into
yes, yes, I remember this, yes,
but I changed the little,
yes.
and I was going to go until I got here. That doesn't equal. Everything's most probably didn't make this clear.
So send me, okay, yeah, no, I will check it, because I can't straight away answer you this. Is, yes,
Is
send
it
me,
okay if I guess, if I send you this whole thing?
yeah, just send me the whole
Because
thing.
it's got all of it.
If you have all of your questions, just say in original, just say which one you want to, slope different, yeah, which way is it, that's, and I will check it out. Okay, so I just need to switch back to that 252. So we can